Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to work upon a Leetcode medium problem, threesome, which in my opinion should be a Leetcode hard problem. And so let's understand the problem statement. We are given an integer of array and we need to return all the triplets where the sum of all those three values turns out to be 0, and we need to make sure that all the values of I, j and k, which means all three triplets, should be posted at different positions. What I mean by that is, suppose if we are given an input like this 0 0 0, we can actually return these three values because they are three separate values whose sum becomes 0. But if we are given a value like this, just 0, we cannot return any triplets because this is just one value, and even if we find I equals to 0, we still don't have any value for j and k. So we will keep this in mind. Also, this problem is actually an extension of the two very popular LeetCode problems, twosome and twosome2. So I highly recommend, if you haven't solved these two problems first, I have created videos for both of them. So go ahead and check out these two problems. And once you understand these two, we will uh, try to solve the threesome problem, because this problem is actually built upon the solution of these two problems. So it would become really easy to understand. Suppose we are given values like this. Okay, now let's see what the brute force approach would be. In the brute force, we would simply run three loops and we will find every single possible triplets to find that what are all the values that we can achieve. So we would run a loop like this, and then in the second loop, we would start from the second position and try to find the pairs and see if we find any pair that sums up to the value 0. If I write the pseudocode, it would look something like: I run a for loop that is starting from first position to n minus 2. I would run a second loop that would start from j equal to first position, and that would run it until the second last position. And I would run a third loop k that starts from the second position and that runs up till n. And eventually I would find all the possible pairs that sum up to 0. But what are the issues with this approach? Basically, the time complexity is horrendous. We would find the answer in big O of n cube time, which is completely not acceptable. So we would need to find a better approach. Let's see what the better approach could be. Now let's try to sort the input array and see if it makes easier for us to find the triplet values. And the answer is yes, it becomes easier if we sort the values. So the sorted input array should look something like this. Okay, now once we have sorted the array, what we are going to do is, first of all, we are going to take any given value in the array, and we would check that whether the complement of this value exists in the remaining portion of the array. So basically, we would use the solution that we have used in twosome2 problem, where for every single element in the given input array, we would have two elements stored in the remaining array, left and right, and we would try to keep adding up the sum of these three values, the current value we are on, the left value, and the right value, and depending on the sum, we would either move the left pointer to the right side or we would move the right pointer to the left side. And let me show you by an example what I'm trying to say. Okay, so we start our solution at the first element, and we see that current value of I is -5. Now, for the remaining portion, we set up two values. One pointer is left pointer and second pointer is the right pointer. So current left pointer, the value of left pointer is actually -2, and the value of right pointer is 3, which are showed over here, left and right, and this is the current I value we have. Now when we start the changes, we will take summation of all these three values, I plus L plus R, and the sum value we actually get is -4. So over here we find that the sum of the current I and L plus R is actually -4. So the value is actually less than 0. If the value is less than 0, which means that our current sum is actually too little and we need to increase the value of our sum. How can we increase the value of our sum? By moving the left pointer to to its next value, because all the values that are right to left pointer are actually higher than whatever value we have at current left pointer because the array is sorted. And let's try to do that. So now the L pointer gets shifted to one space to the right. So this becomes our new L pointer. R remains same and the values we have is I is still at -5, left is at 0 and right is at 3. If we do the sum again, now for the second iteration the summation we get is actually -2. So again the value is still less than 0, which means we need to increase our sum. And how to increase our sum? Again we would update the left pointer and move towards the right side. If we do that, the value of our left pointer becomes 1, and let's do the sum again. So I and R remain same and the value of left becomes 1. So the new sum is -1, which is still less than 0, which means we would update our left pointer again. And now if we do the sum of these three values, we get 0, which is exactly what we want. And we would add it to our list of triplets that we need. So in our result, we would add the values of -5, 2, and 3 as our result. And once we are done with the first value iteration, we would continue to see if we can find the second pair. Now we will start with second point as our ith value, and we would check in the remaining subarray to see if we can find the solution. So current values of I is equal to -2, L is equal to 0, and R is equal to 3, which means the sum of these three values is actually +1, which means that this is greater than 0. So we need to reduce the value of the sum. And how can we reduce the value of the sum? If we move the left pointer from here to left side, because all the values that are left of the right pointer are actually less than whatever the value at right we had, so we can potentially find a lower solution that sums up to 0. And now let's see what the new values would be. The I and L will remain same, but the value of R would actually become 2. And if we do sum of these three values, the sum is actually 0, which is exactly what we want. And now we can add these three values to our result node. Okay, now let's see if we can find new pair from here. So in the given example, if we see that if I is at value number 0, we do not find any other pairs that sums up to 0. And the moment we get to this value where I is actually equal to 1, we know that this value is positive, which means all the values that are after 1 would also be positive. So it would not be possible for us to find a pair of three values that actually sums up to 0. So at all the positions, on the sum of any three values greater than 0, which means we can stop our loop at this value. We can return the result with these two values. Now this solution works perfectly fine, but we did not consider one case where we have to check the values of I, are not equal to value of j and are not equal to value of k. We are not doing this check, and let's see how can we implement this check. We can do it simply by putting a condition that other than the first value, if we are at any given value and we try to check that whether it should be part of this result node or not, we can simply add a condition that if the value is actually same as the value on the left of it, we can simply skip this value and we would just move forward. So let's take that by an example. Suppose we are given an example like this, and we try to run our algorithm. First of all, we will sort all the values. Now, when we are at first value, we would try to see that can we find a potential tuple. And yes, when we are at the first value, if we set up the values of L and R to here, we can find a result node where -3, 1, and 2 would become the part of the solution. And our job is to make sure that we do not find the same pair in our result node, which we can see that exist in this given input array. If the second value of I is actually this one, we would also find the same L and R for the result, and we would find another triplet that sums up to 0, -3, 1, and 2. But notice that these two values are same, and we need to avoid this at any case. So one way to avoid that is when we found out the solution for this particular value with left and right being here, and we found out this solution. When we move to in our loop, when we move to the next value, we would simply check that whether the value on the current I, if is it same as the value of the I minus 1th element, and in this case it is true, both values are same, so we would simply ignore this value and move our loop from the next value onwards, and this solution would work perfectly fine. And when we are doing the left and right check, we will also do the same thing. Suppose our input is like this. So notice over here that whenever we are at value number 5, we can have two potential solutions. It's either value number 5, this 2, and this 3. This sums up to 0. Or we can find a solution like -5, 2, and 3. And in both the cases, we can see that the value of left pointer is actually same, and we should also try to avoid this duplicate scenario as well. So whenever at the first instance, if we find out that the pair do exist, that we need to add to our result node, while adding our result node, we would check between left and right pointer that whether the value that is next to the current left pointer, if they are same or not. If they are same, we would simply update our left counter so that we do not encounter the similar values in our solution. And this will make sense when we get to the coding. The time complexity of our algorithm would be big O of n square because we will need to run the loop twice. First is to calculate the value of I, and second time we need to calculate the value of L and R for every single ith value, which creates a time complexity of big O of n square. And this is much bigger improvement than our brute force approach, which had the time complexity of big O of n cube. Let's move on towards coding solution. First, we will sort the given input array, and we would create a list to store the result. Now we will run a for loop to iterate over the sorted array, and with every value of I, we would try to find subsequent value of left and right that sums up to 0. We would put a condition over here that if the value of current ith element is actually greater than 0, we will simply terminate the loop. Now we'll create a condition to see if the given element is not exactly the same as its previous value. And if this condition is true, we would call our function toSum2. And in the input, we will provide the input array, ith position, and current result list. So now let's create the toSum2 function. Inside toSum2 method, we would create two variables to store the value of left and right, and left would be I plus 1, right would be array length minus 1. Now we will run the second loop to find the correct value of left and right. Now we have created a parameter sum to calculate the total of I plus L left plus right value. If sum is less than 0, we update the left pointer. And if sum is greater than 0, we reduce the right pointer. If none of these conditions are true, which means our sum is exactly 0, and this this triplet can be added to our result. And now we just check that if the value of left is the same as the value of left plus 1, we would simply update the value of left pointer so that we don't encounter the duplicate values between this j and k values. Once this chunk once this chunk of code runs, our result should be stored in this result parameter, so we can simply return that as our answer. Now let's try to run this code to see if it runs. Looks like we messed up. Okay, so basically we didn't update our values. We did not increment the values of left and right before moving on for this loop. So that's why we were seeing the error. The bug has been resolved, and yeah, our solution seems to be running fine. Let's try to submit it. And yes, we can see our solution works perfectly fine. And there is also another way. If we don't want to do this, and if we don't want to check between these two values, left and left minus 1, to avoid duplicates, and that is to use hash set. And the hash set solution, I would post it in the comments so you can check it out over there. But it's pretty trivial to understand, and that is just another approach that we can take if we don't want to put down these two checks in our loops, one over here and the other one over here. It takes a lot of time to make these videos, and I would really appreciate if you can just let me know that how do you feel about these videos, and if you want me to change anything in the format. I really hope that you liked it, and thank you so much.